Okay, so now what we're gonna do is we're gonna solve house robber number one because we already solved house robber number one previously. I'll attach the link of the YouTube video. Where I solved the question, and this is the notes I made while we were solving it. So what we're gonna do is we can take the help of I'll take the help of this notes that I discussed in the previous version of this problem, and we'll understand how to solve house robber 2. Right. House robber 2. So what the game in House Robber 2 is that you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. So all the houses are arranged in a circle. All houses are placed in a circular way. Right. So that means the first house is the neighbor of the last one. Meanwhile, adjacent houses have security systems connected, and it will automatically contact the police if adjacent houses were broken. Given an integer array representing the amount of money each house, return the maximum amount of money you can rob tonight. What they said is if the robber starts from here and if he goes all the way around and reaches here, then he can't rob this house because the last house neighbor is the first house, right? So that is the constraint that we have in this question is houses are arranged in circular direction. All right. So as houses are arranged in circular direction, what we are supposed to do here is we can take from 0 to n minus 2, ignoring the last house, and we can take 1 to n minus 1, ignoring the first house. Right. We're gonna ignore the first house and we're gonna take maximum of both. Maximum of both and return. That's what we're gonna do. So the robber will find the profit that robber is gonna gain when we start from first house and reaches last but one house. And then we're gonna check from first house to the last house how much profit he's gonna gain. And from this both we're gonna choose the maximum. Right. So how we're gonna find the maximum that we discussed in House Robber Bob 1 where we discussed about recursion, we discussed about memoization, we discussed about tabulation, and also space optimization. The space complexity is pretty much gonna be the same as of house robber 1. So let us code this up now. First, I'll just go sequence wise. So first, let us do recursion. So enter recursion. I is less than none. What we're gonna do, we're just gonna declare n value instead of size n minus 1. What we're gonna do, we'll just keep it as n. We'll keep it as temp1. Gonna keep it as temp2. If I is not equal to 1, 0, ignoring the first house. So we're gonna push every element inside the temp. And now we're gonna ignore the last one, last house. ANS1 and ANS2, we're gonna return max of ANS1, ANS2. Recursion of n minus 2, temp1, recursion of n minus 2, temp2, and then one is gonna be return nums of 0. So let us run and see So our recursion function is correct. So now what we're gonna do? We're gonna do memoization, which is pretty easy. Memoization. What we're gonna do? We're gonna initialize dp vector with -1 dp dp vector and dp. Okay. If dp of n is not equal to minus, we're gonna return dp of n, and we're gonna save dp value. Now let us see where exactly we go wrong. I'm sorry, it's gonna be n plus 1. So, okay, why is this wrong? Hmm, okay, let us maintain 2 dps. I think we're getting error maybe because we are maintaining a single dp value. dp 1, dp 2. Okay, let us see. Yeah. So here we have to maintain 2 dps because we are maintaining 2 temp arrays, while one is ignoring the first house, while the other one is ignoring the last house. So this is how we're gonna do memoization, and similarly we're gonna do tabulation, and then we are gonna do space optimization. Right? Yeah, that's how we're gonna do. We'll just have a 2 for loops basically. I is equal to 0, I is less than. It's not gonna be here. It's gonna be yes. So what it's gonna be is, yeah, it's gonna be for int I is equal to 0, I is less than temp1 dot size I plus plus mm, int pick dp1 of 0 is gonna be temp1 of 0, right? So pick is gonna be temp1 of I plus, what do you do, dp of 1 is gonna be max of temp1 of 0 temp, and here we're gonna iterate it from 2 I minus 2. Int not pick is going to be temp1 of 0 plus dp of I minus 1, right? We are gonna remove this whole thing. We're gonna remove this whole thing. dp1, let us keep it as dp1. So dp1 of I is gonna be max of pick and not pick. dp2 of 0 is gonna be temp2 of 0 dp it's gonna be temp2 and now we're gonna use the same for loop. Let's just copy paste this and we'll just change the values. temp2 dp2 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 dp1 of n minus 1 dp2 of n minus 1. It's the same for, oh yeah, it's giving -1 for everything. Alright, n minus 2 and n minus 2. Oh yeah. N minus 2 because the dp size here is n minus, the dp size is n minus 1, so that's the reason why we're gonna take n minus 2 and n minus 2. Let's see if this works out. We got a runtime error. Let's see why we got a runtime error. What I did is, here we are getting out of bound error at this line because, for suppose if temp1 has only one element, then it will go out of bound if we trying to access the second index, right? So that's the reason we are checking if we have temp size greater than 1, only if then we are proceeding further. Yes, yes, it worked. So we are just checking that we are not going out of bound for both the temp 1 as well as temp 2. Right. So that's how we solve this. Like we can further optimize it using space optimization where we use two variables pick and not pick, and we can do it instead of taking DP array of size, and we can just n minus 1 essentially, like two arrays we are taking of both of each n minus 1. We can just take variables for each DP and two variables for each DP, and we can iterate them consecutively, just like how we discussed here. That's how we can do it for this too. So yeah, that's it.